Have you ever wondered what toys do while you're not looking? Maybe they have a life of their own outside our field of vision. When we're around, they seem to follow the usual rules of how toys should act in our everyday world. Hi, my name is Kate. I'll show you why this question isn't as silly as it sounds. Today, we are already familiar with things having a life of their own, to which we do not have access. So, when we watch them, they act the way they're supposed to, according to the laws of physics today. What are they? And how discreetly can we peek at them? I will reveal this mystery to you. I invite you to an experiment, double-slit experiment. To start, grasp a few basic physics principles. Here are these small balls that represent matter particles. We will watch their movement. If we shoot at the target with a gap using small hard balls, we will see one stripe on the screen toward which the balls are heading. If there are two slits, two stripes will appear. Let's look at the behavior of the waves. The waves went through the slit and hit the screen most forcefully right behind it. If there are two slits, the peaks of the waves will meet and magnify each other. This causes multiple stripes to appear on the screen. Now we have covered the basic theory. Now let's get to the most interesting part. I invite you to the quantum world. Ladies and gentlemen, before you is an electron. An electron is a tiny piece of matter, just like a small ball. We will shoot a stream of electrons through a single slit. The screen will show one stripe as we expect. On the other hand, with two slits, we should observe two stripes on the screen.
However, there is more to it.
When there are two slits, the pattern on the screen mirrors the image formed as when a wave passes through both slits. How? You might say, this is impossible, because after all, we shot the electrons, tiny bits of matter, and as a result, got a picture as if they were not balls, but waves. How can pieces of matter form a pattern of overlapping waves? It seems nonsensical. Scientists tried to solve it, coming up with many theories. An electron may begin as a particle, transform into a potential wave, pass through both slits, and then manifest as a particle on the screen. This is quite unusual, but this has validity. We need to test it by tracking the electron through the measuring device. Magic. When we watch electrons, they act like regular matter, showing two stripes instead of many as they did before. It's like the electrons decide to behave differently, almost as if they know we're watching. This experiment raised more questions than answers. Some people think that watching the electron can change where it is and mess up the measurements. In that case, can reality really exist without an observer? Or does this experiment suggest a different conclusion?